Hi, this is the second part of my project presentation, and in the first part I have explained about the design and implementation of the OFDM communication system in MATLAB. I also spoke about a possible solution to the PAPR issue in OFDM systems and introduced the solution of a PTS algorithm. Now, in this video, I would like to demonstrate the MATLAB implementation. If you have not watched the first video, please watch the video before this video. The link is provided in the description. Let me start with the implementation of the PTS algorithm. So in order to run the PTS algorithm code, we first need to import data from an IQ vector file. In this project, I have used an LTE IQ vector. So let me open the IQ vector file. If you see to the right of your screen, in the workspace, the data is loaded now, and now we are ready to run the PTS algorithm. So this is the output that I discussed in the first video. So now the blue curve represents PAPR without PTS algorithm. The red curve represents PAPR with PTS algorithm. You can definitely see that there is a reduction in PAPR when PTS algorithm is used, as represented by the red curve. Here we are using CCDF to quantify PAPR. CCDF, the definition of CCDF is similar to PAPR, and that is why we are using that. So we can conclude that PTS algorithm is very effective in reducing PAPR. Now let me show you the demonstration for OFDM communication system. Here the OFDM communication system, as shown in the block diagram, is divided into different subsections. So first, before designing the transmitter part, we have to define the block size, the number of subcarriers, number of data bits, and the length of the cyclic prefix. We then go on to model the transmitter and the receiver of the OFDM system. In the transmitter side, we choose QPSK modulation, and we also perform IFFT on the 4 different subcarriers, and then we add cyclic prefix, and then we transmit the OFDM signal through the AWGN channel, as shown in this section. In the receiver side, we perform the reverse operations as already discussed. So now let me run the program for OFDM communication system. So I'm going to explain the results in a backward fashion. So this is from the receiver side. At the receiver, we are going to receive signal with some error. So we will not be able to recover the input data sequence as it is. We will be definitely seeing some errors. Now this is the FFT stage before the demodulation at the receiver side, where we can see the FFT performed on all the 4 subcarriers. This is before the FFT stage, and the cyclic prefix is removed from all the 4 subcarriers. This is the OFDM signal after passing through the channel. I want to compare this with the OFDM signal before transmitting through the AWGN channel. As you know, AWGN channel is used to mimic the noise that is present in real world scenario. Therefore, you can clearly see the difference between the signal on the right and the signal on the left. The signal on the left is after passing through the AWGN channel. The signal on the right is before passing through the AWGN channel. There is considerable noise that is introduced after passing through the channel, and that is what I wanted to depict here. Next, we'll look at the orthogonality. Here, as you can see, the 4 subcarriers are represented by 4 different colors, and you can see they're completely orthogonal to each other at any point. This is the main feature of OFDM. This is a cyclic prefix added to the subcarriers before OFDM transmission, and this is in the transmitter side. This is the IFFT performed on all subcarriers before the addition of cyclic prefix. This is the conversion of series data stream into parallel data stream and the generation of subcarriers. This is the QPSK modulation performed on the input data sequence, and this is the original data sequence that we chose. So this concludes the demonstration. So I would like to conclude the presentation as well by saying that we were successful in developing and designing an OFDM communication system, and also in developing a solution for the PAPR issue that prevails in the OFDM systems. During the course of the project, I was able to study MATLAB and come up with a design for OFDM communication systems. Our OFDM systems were also thoroughly analyzed. These are the references that I used. I would also like to thank Dr. Dapeng Wu for giving me the opportunity to perform well in this project. Thank you.